Hi, my name is Chris Freeman. I'm here to talk today to my students about their AP Environmental Review session on Earth systems and resources. So this first image that I've pulled up from online here that you should be looking at is of the geologic timescale. And really, I don't want you to spend too much time studying all of these different terms. I just want you to understand that an eon is a much larger span of time than an era, and then we go into periods and so on and so forth. The key here is that an era would be a subcategory representing an event or a specific section of time of an era, and then we can categorize into smaller and even smaller sections. So you should be loosely aware of some dates associated with eras, and you should be aware that the Holocene is representing today, although we can argue that and say that we have now created a sixth mass extinction that has brought us into the age of man, where man is a dominant influence on the earth, and we're seeing a lot of plastics and stuff that will become part of the geologic time record, along with a lot of extinctions. So this is something that you should be looking at a little bit, that you should understand the difference between an eon, an era, and a period. You should be aware of some of the events, like when dinosaurs were around, and some of the mass extinction events. And let's jump to that real quick. So there are 5 mass extinction events that you should be aware of, that you should sort of hone in onto. And typically what the main focus is, or what is the largest, most dramatic, scary mass extinction event. And that happened here. So you should be aware that about 250 million years ago, we had a major mass extinction event called the mass dying, dun dun dun, and the bulk of the organisms, the critters, everything on Earth died off. Upwards of 90+% of all living things died off, and life had to start sort of anew from there. So that's really, really important. That was way more significant than when the dinosaurs died off 65 million years ago. Uh, the big extinction event out of the 5 was during the mass dying. And we can argue and say that there's a 6th one today, and that now we have entered into the Anthropocene. But that's not something that you need to worry about too much on the test. What you need to be focusing on are remembering these 5 extinction events. Now, let's move along from geologic time. Those are the quick, roughed out reviews of that. I do want you to be aware that we have convergence when things come together. We have pulling apart of plate boundaries, which is divergence, and then we have transform when they slide past each other. Those are things that you need to be aware of in terms of plate boundaries. Sometimes they'll ask you about specific examples of plate boundaries. Iceland is a great example of divergence, right? And then we have convergence, where we have the Himalayas being built. India is getting pushed into China, and that's creating the Himalayas. And then for a transform plate boundary, the San Andreas Fault is a really great example in California of that. And so you should really have these at the ready as examples of plate boundaries, where they might be. You should understand that volcanoes and earthquakes are going to be happening along these plate boundaries. That should be important for you to be aware of as well, in terms of some content to be looking over and studying and thinking about with plate boundaries. The driving force behind of all this plate movement is convection in the mantle. So we have convective currents. The mantle's behaving as a plastic and pushing our continents around. So that should be something that you look into a little bit more, but that's something to review, think about, study. And let's talk a little bit about earthquakes. I like to think about my skin when I think about earthquakes. We have the epidermis, which is, on your skin. That's on the surface of you, right? So epicenter is happening above the focus. The focus is inside Earth where the earthquake happens. And then we have on the surface the epicenter. Don't confuse those, right? So where we have an earthquake occur, it's often inside of Earth, somewhere inside Earth. That is the focus. And then directly above that, on the surface where you start to see damage, that is going to be the epicenter. And that gets measured by the Richter scale. And the Richter scale is one of those things, along with the pH scale, of something that goes up in magnitudes of 10. It's a semi-log scale. It's going up by magnitudes of 10. So that's something that you also need to be aware of. So that will be good to review. We also want to think about different types of volcanoes and where they occur. So we have shield volcanoes. They're like the gentle giant. They're, think Hawaii. This is where we have the tallest volcanoes, but they're also the widest, much wider than they are tall. And you could romantically hold hands with a significant other and watch lava flow down and not really be in fear for your life. But then we have strato or composite volcanoes. They're all around the Ring of Fire in the Pacific. The stratovolcanoes or the composite volcanoes, they're the dangerous ones. You wouldn't want to be romantically holding hands with someone when that goes off, because that explosive pyroclastic flow will be shooting at you upwards of 1,000 miles an hour and just wipe you out. And that would be tragic and terrible and not worth holding hands over. So those are the dangerous volcanoes. They're the ones that are significant because they can get up into the stratosphere with their sulfur dioxide and actually change climate. So they can adjust and send us into an ice age with their sulfur dioxide, blocking solar radiation from getting into Earth. So that's an important thing that affects that's the sulfur cycle's effect on climate shifts. Mount Pinatubo is a great example of that. In the 90s, we had that erupt, and then we saw cooler global temperatures for a little while as a result of that. And there have been a number of other historic volcanoes that have also been of relevance there, creating the year without a summer in 1815, and so on and so forth. So let's move away from some of these geologic content, and let's talk about carbon through the seasons. And so I just want to talk about our seasons. Earth's tilt is at 23.5 degrees, and it wobbles a little bit, whatever. But what we need to think about really is the relationship of Earth's tilt and our sun, and where the most concentrated sunlight hits, which is the equator. And because we have more land mass in the northern hemisphere than we do in the southern hemisphere, we have a lot more trees in the northern hemisphere. And as a result of that, during the winter solstice, when more direct sunlight is hitting our southern hemisphere, our northern hemisphere experiences a winter, and a lot of those trees lose their leaves. And as a result of that, we don't have photosynthesis taking place. And so if you look at this nice graph that I have here for you, we have this up, down, up, down, up, down movement that's indicative of the seasonal change of carbon emissions getting absorbed or not getting absorbed by the amount of trees. And it's really the difference of trees in the northern hemisphere versus the southern hemisphere. And we should note that we see this increase of carbon dioxide regardless of that seasonal variation, because we're putting more carbon dioxide into the atmosphere through industries like coal-fired power plants and car emissions, burning of fossil fuels. And that's what's creating this huge spike. But that up, down is important to be aware of. And this has been a small part of your review session. I'm going to continue with part 2 of Earth systems shortly.